Hello everyone, welcome to the course on basic and advanced plotting in Python for Science and Engineering Masterclass. Let me first give you a little introduction of myself. I will be the course instructor and my name is Manavendra. I have a background in physics and I have done my PhD in condensed matter physics from the Indian Institute of Science in Bangalore. I have been teaching online for almost 10 years now. You will learn how to use Python to create stunning graph and data visualization in this course. Students, researchers, and data scientists who want to create amazing figures for scientific illustration should take this course. Now the important question is why you should take this course. The simplest method of data interpretation and integration is via visualization. Visuals make a complex problem simpler to understand. The practice of displaying information in the form of graphs or charts is referred to as data visualization. It makes it much simpler to understand enormous and complicated amount of data. It makes decision making highly efficient and makes it quite simple for decision makers to spot new trends and patterns. Data visualization is one of the most critical elements for your academic career, whether you are a graduate or undergraduate student, researchers, or a scientist. In this course, I will teach you how to visualize data using Python. Data scientists will also benefit from this course. I will start with the fundamentals and make my way up to more complex plotting for posters and scientific papers. So this course is for students who are undergrads or grad students or researchers. This course is also very important for data scientists or students or people working on machine learning having difficulty in data interpretation, or someone who wants to explore dimensionality of the data, or more importantly if you want to publish your work in a scientific journal or a conference paper. So first I will give you a quick introduction to Python. Along with that I will speak about the important packages we will use a lot in this course, such as Numpy, Pandas and Matplotlib. I will begin with the basics before moving on to more sophisticated planning for posters and scientific articles. At the end of this course, you will be able to plot any kind of data from various types of data files. Now, why we should choose Python for data plotting? Python, in my view, is one of the greatest platform for data visualization. Its ecosystem include a variety of libraries for building interactive dashboards as Bokeh, Matplotlib, Plotly, Seaborn, and Plotly Dash. There is a significant online community for Python which is free and open source. When compared to other data plotting applications, the graphs produced by Python are entirely customizable and of the highest quality. Python also functions flawlessly on all of the major platforms including Mac, Windows, and Linux. In addition, major universities and tech giants such as IBM, Google, and Microsoft all use Python in their labs. Because of this, Python is a better choice for data visualization than programs such as MATLAB, Igor Pro, or Origin Pro, which comes at a hefty price. So let's install Python. The simplest way to install Python is to use the Anaconda distribution. So first open anaconda.com and then click on download. Alright, so let's install Anaconda. Click on next. Click on I agree. You can just leave with the default settings. Click on next. Click on install. So we have successfully installed Anaconda. So once you open Anaconda Navigator, you have different options. You can open Jupyter Lab, Jupyter Notebook, and Spider from Anaconda Navigator. So here we will be using Jupyter Lab for this course. So let's click on launch. So this is the interface of Jupyter Lab. Now Jupyter Lab has been a must-have for any data scientist or data analyst who works with Python. I will be using Jupyter Lab for this entire course. The advantage of using Jupyter Lab over Jupyter Notebook is that you can open several notebook files in different tabs. To create a new notebook, click on this. You can rename the notebook. So now here you can either write a code or you can write Markdown. So why we should consider Matplotlib? So Matplotlib is a plotting package for Python that makes it easy to make two-dimensional plot from data stored in lists, Numpy arrays, and Pandas data frame, among other data structures. You can make plots, histograms, power spectra, bar charts, error charts, scatter plots, and etc. with just a few lines of codes. So let's get started with Matplotlib. So let's start with Jupyter Lab. Let's create a new Python 3 notebook. Let's rename it to test plot. So let's create a simple plot to start with. We must import Matplotlib in order to set up and operate in our environment. So let's plot a basic sine function to understand the plotting. So pyplot has methods that can be used to add different parts to figure objects, like making the individual plots as axis objects known as subplots. So let's also import Numpy. Numpy is required to create an array of elements. So this will create a linearly spaced array of elements starting from 0 to 10 with 101 elements. As you can see, this is a simple plot with sine function. Now let's add X label and Y label and title for this plot. So now we have added our X label, Y label, and we also have a title for this plot. Now let's understand Matplotlib plotting in a bit details. So Matplotlib takes an object-oriented approach to plotting. This means that the plot can be built gradually by including new elements. So the figure consists of the entire area that includes one or more plots, and the axis represents the individual plots within the figure. So in the last class we learned how to plot a basic sine function. In this lecture we are going to customize the plot and add second plot. Okay, let's customize the plot. So first let's change the font size. As you can see, this font size looks a bit smaller, so we can increase the font size. So we will increase the font size for X and Y label. So we can see that the font size for X label and Y label is increased. Now we can also increase the font size for X tick and Y tick. So we can see that the X tick and Y tick font size are increased. Now we can also change the font size for the title. So now we can also set the limit in X-axis and Y-axis. Let's say we plot from 0 to 8. Let's change the limit from 0 to 1 in the Y-axis. So now you can also change the line width of this plot and also change the color. So let's line width equal to 1. So it's too thin. Let's make it 4. Okay, so now you can see that the lines are very thick, and now we can also change. So let's make the color red. So now we can also add a legend. Let's increase the font size of the legend to 14. So you can see there is a black border line along the legend. If you want to remove this border line, just type frame on equal to false. So you can see that the border is gone. So now let's say we want to only keep the X ticks like 0, 2, 4, 6 and 8. So we can do that here. So as you can see that now the ticks are only appearing at 0, 2, 4, 6 and 8. Similarly, we can do this for the y-axis also. So you can also add latex symbols to the x label and y label. So instead of x label, I will put theta, let's say. So in order to use a LaTeX code, you have to add R here. So you can see now it's changed to theta. So for instance, similarly, you can add another plot here. For instance, let's plot cosine x. Let's define the color as blue. So you can see now we have sine and cosine x and the legends are shown. Now you can also change the figure size here. So in this case, the figure size is 6 inch by 4 inch. So we can make a square figure. In this case, it will be 6 inch by 6 inch. As you can see, this is how it looks. So in the last class, we learned how to plot a basic sine function. In this lecture, we are going to customize the plot and add second plot. Okay, let's customize the plot. So first, let's change the font size. As you can see, this font size looks a bit smaller, so we can increase the font size. So we will increase the font size for X and Y label. So we can see that the font size for X label and Y label is increased. Now we can also increase the font size for X tick and Y tick. So we can see that the X tick and Y tick font size are increased. Now we can also change the font size for the title. So now we can also set the limit in x-axis and y-axis. Let's say we plot from 0 to 8. Let's change the limit from 0 to 1 in the y-axis. So now you can also change the line width of this plot and also change the color. So let's line width equal to 1. So it's too thin. Let's make it 4. Okay, so now you can see that the lines are very thick, and now we can also change. So let's make the color red. So now we can also add a legend. Let's increase the font size of the legend to 14. So you can see there is a black border line along the legend. If you want to remove this border line, just type frame on equal to false. So you can see that the border is gone. So now let's say we want to only keep the X sticks like 0, 2, 4, 6 and 8. So we can do that here. So as you can see that now the ticks are only appearing at 0, 2, 4, 6 and 8. Similarly, we can do this for the y-axis also. So you can also add latex symbols to the X label and Y label. So instead of X label, I will put theta, let's say. So in order to use a LaTeX code, you have to add R here. So you can see now it's changed to theta. So for instance, similarly, you can add another plot here. For instance, let's plot cosine x. Let's define the color as blue. So you can see now we have sine and cosine x and the legends are shown. Now you can also change the figure size here. So in this case, the figure size is 6 inch by 4 inch. So we can make a square figure. In this case, it will be 6 inch by 6 inch. As you can see, this is how it looks. Okay, now that we have customized our plot, the next important thing is to export our plot. So there are two ways of saving these plots. You can save it as raster based images such as JPG, PNG or TIFF, or vector based images such as PDF or SVG. So let's save the figure. So if you are saving this image as PNG or JPG, then you need to define the DPI. But if you are saving this image as a vector based graphics like SVG or PNG, then DPI command would be overlooked. So this ensures that your exported image is tight in page, and you also want a transparent background. So I put transparent equal to true and DPI equal to 400. So let's click it. So as you can see, we have saved the image as PNG. Now let's also save as JPG. Now let's see how the plot looks. So this is the JPG image of the plot. You can see it looks very good. And this is PNG, which is in transparent background. So this is in PNG, which is in transparent background. That's why it looks dark. Now let's save this plot as PDF or SVG. In that case, you don't need this DPI. So you can see the PDF is saved. Now let's also save as SVG. So the SVG file is also saved. Now let's open and check. So this is the PDF. As you can see, it looks very nice. You can zoom in, and since it is a vector based graphics, it will never get pixelated. Let's open the SVG file also. This is the SVG files. It looks great. Sometimes we need to create set of plots within one figure. This can be done using subplots. Let's see how this can be done. So here we have created a figure with 2 rows. Similarly, we can also make a figure with 2 columns. And you can increase it to 3, 4 and 5 depending on how many figures you need. You can also specify number of columns and rows. Let's say we make 2 rows and 2 columns. Therefore, using this subplot, you can create n number of rows and n number of columns. So using this, so let's create 2 rows first. And let's plot this data in 2 different subplots. So AX0 corresponds to the first subplot and AX1 corresponds to the second subplot. So as you can see, this is the first subplot, and then we can also add a legend. Similarly, we can plot the second one. In this case it will be ax1, this is y1. As you can see, we have two rows. Now we can do this with two columns also. Now you can see that the tick label for the second plot touches the margin for the first plot, so we can adjust this using this tight layout command. As you can see, now the tick labels are separate. So using these subplots you can create variety of plots. Many times when the extent of the data is large, it is hard to visualize the data in linear scale. And in this case we have to plot the data in log scale. So either you can do log scale in y-axis or log scale in both axes. Let's see an example. Suppose we have an exponential function. Here you can see that the extent of data starts from 0 to 20,000 along the y-axis. So it is convenient to plot the y-axis in a log scale. Now you can see that y-axis is in log scale. You can also plot both the axes in a log scale. For example, so as you can see now, both the x-axis and the y-axis are in log scale. So depending on the data set and the extent of data, you may either want to plot in semi-log y or in a log scale. Suppose we have a situation where we have two functions. So for example, in this case we have sin x and another function is sin x plus x square. For both functions we have the similar range in the x-axis. Now if you plot these two functions together, because the value of y1 is much smaller than y2, y1 will be blown away. So let me show you what I mean. So here you can see that y1 is almost blown away because y2 is very large. In such a situation, what we are going to do is that we are going to plot y1 and y2 in two different y-axes. So let's plot y1 along this y-axis and let's plot y2 along this y-axis. In both cases the x-axis would be similar. So let's do it. So now we have only plotted y1. Now let's plot y2 along this axis. Now you can see this plot looks much better, where we can see the features in y1 and also we can see the features in y2. So many times in our plots we need to insert an image. So let's see how we can insert an image in an existing plot. So in this case I have this image, which is the image of my device in PNG format, and I would like to insert this image in my plot. So let's see how this can be done in Python. So in order to import an image, you need to add this import matplotlib.image module. Now let's add the plot and remove the axis label for this picture. So as we can see, we have created a figure window which has an imported image and also the plot. In this section, we will learn how to import experimental data and plot using Python. Suppose you have a data file which looks something like this. So here you have data in two columns separated by a space. Now let's import this data and plot using Python. So first we will import Matplotlib and Numpy. Now let's import this data file. So since we have space between our data points, since we only have space between our two columns, I will put delimiter equal to none. In case you have comma, you need to put appropriate delimiter here. So now we can see that we have two columns. The first column is the x-axis and the second column is the y-axis. So now let's read both these columns and plot it. So this is the first column. This is the second column. So this is how the data looks like. Now you can also put X label and Y label. So my X label is gate voltage in volts and my Y label is resistance in kilo ohms. This is how the plot looks like. Now suppose you have another data called data1. Now in some data file you also have a header which is a string. So in this case you can see this is voltage and this is resistance. So the first row is a string. Now if you try to run this code, you will end up with an error because in this array there is a string characters. Now in order to ignore the header or the string, we can skip the first row. As you can see, now it works perfectly fine. If in your data you have more additional strings, you can appropriately ignore these rows. So in this lecture we are going to learn how to import CSV files and plot them using Python. So suppose we have a CSV data file which is shown here. So this is the CSV data file what we have, and we would like to import this data file and plot it using Matplotlib. So this is the CSV data file and we can see that it has 3 columns. So now let's import this CSV file and plot it. So in this case we have three columns. So the first column is my x-axis, and the second two columns are two different values of y-axis. So let's call this y1 and let's call this y2. This is a plot between this column and this column. Now let's plot y2. So as you can see, this is how the data looks like. So in this lecture we are going to import a mat file, and we are going to extract the data from the mat file and plot it using Matplotlib. So this is a data file which is generated using MATLAB, and it has an extension of data.mat. So in order to open a mat file, we need to import a package called scipy.io. So we have loaded the data.mat file. Now let's print it. So as you can see, it looks pretty complicated, but in this data file we are interested in these gate voltages and we are interested in these scans. So let's extract the data for this particular variables gate voltages and scans. Now let's check the dimensionality of our X data and Y data. So in order to plot this data, we need to do a transpose because the data is 1,201. So this is how the data looks like. So in this lecture we are going to learn how to import .h5 data file and extract the data. So we have a data file called data0.h5, and let's open this data file and plot it. So in order to work with h5 files, you need to import a module called h5py. So let's do it. Now let's see the content of this h5 file. Now let's extract the data. In our case, the x data is the x array and y data is r2x. Now let's plot it. This is how the plot looks like. So in this lecture we are going to learn how to import multiple data files and plot in Python. So let's get started. Here we have 6 data files in CSV format, and we would like to import all the data files and plot them together in Python. This is a common situation in experimental conditions where you want to plot multiple data sets in a single plot. So let's see how we can plot this using Python. Another thing to note is that the path of this data folder is different from the path where we are having the Jupyter notebook. So let's get started. So right now you can see that in this current path we do not have our data files, so our data files are in different folder. So first we need to change the current folder. So here you have to enter the path of the folder. So in my case this is the path of the folder, so I will copy the link of this path. Great. So now as you can see we have data files starting from 0, 1, 2, 3, 4 and 6. So we will be using a for loop. to import all these data files and plot them accordingly. So here we are reading the data files. So the first file is data 0, the second is data 1, third is data 2, data 3, data 4 and data 6. This is how we have the file name arranged here: data 0, data 1, data 2, data 3, data 4 and data 6. Remember, we don't have data 5. Okay, so we are reading. So if you open up a data file, so you can see we have two columns. So the first column is the x-axis and the second column is the y-axis. So I am reading the x-axis, which is the first column, and the y-axis, which is the second column. Now let's plot it. Plot it. As you can see, this is how the plot looks like. So since we have 6 files, we have 6 plots in the figure. So in this video we are going to learn how to plot 2D color maps in Python. So 2D color plots are very important to visualize two-dimensional or three-dimensional data. So here is an example. So we have two variables x and y, and z is a function of x and y. And this is the functional form of z, which is 1 minus x to the power 4 plus y to the power 4 into an exponential of minus x to the power 4 plus y to the power 4 by 2. Suppose we have values for x and y, and then we can compute the values of z and plot it. So this is how the plot looks when we plot it using Matplotlib. So I have taken x from 0 to 2, and I have taken y from 0 to 2, and then I have plotted z. So let's see how this we can do in Python. So let's plot this in Python. So let's define the function z. Okay, so now let's define x and y. So this mesh grid will convert x and y into a two-dimensional array. Okay, so now let's plot this. So this is how the plot looks like. Now we can also add a color bar. So now we have added a color bar to this plot. So in the last video we saw how we can make a 2D color plot. So in this video we are going to learn how to customize a 2D color plot from this to this. So as you can see here, the color bar is relocated in a nice position. We have the X level, Y level, and the fonts are large and elongated, and this plot looks much better than this one. So let's learn how to customize a 2D plot. In the previous lecture we have learned how to make a 2D. So now let's customize this 2D color plot. So there are different color maps which is pre-available in Matplotlib library. You have diverging set of color maps which is shown here, and you also have a sequential color map which is shown here. So you can choose between any of these color maps. In addition, you can also create your own color map. For example, here if you make it, you can see that the color looks much better with this particular color map. Now you can also change the setting depending on your requirement, and you have different kind of settings available here. You can have a setting flat or setting nearest and so on. So depending on your requirement and the way you want to plot, you can change the setting. Let's increase this font size because the font size looks too small to me. So in order to increase the font size, we need to import RC params. I like Arial fonts on my figures. You can choose whatever font you like. So now we have changed our font size. So now let's customize this color bar, and we want to put the color bar here. So in this case, this is the x location, this is the y location, this is the extent in x direction, this is the extent in y direction. As you can see, this is how it looks. So now let's customize this color bar. So now I want this tick label to be on the top. So as you can see, now the tick labels are on the top. So you can change the width and height of the color bar by changing these 2 points, and the location of this color bar can be changed by using this. For example, if I change this to 2, the color bar will be much narrow. So now let's add title and X and Y label. So this is the title. Now let's add X label, Y label. So X and Y are gate voltages. So we have added X label and Y label. Now we can also customize the tick labels. As you can see, this plot looks very good, and we can export this plot to PDF, PNG, SVG, or whatever format is required for publication.